let's examine the distance formula. We want to find the distance between each pair of points. So a pair of points means two. So I have point A, point B, and point C. Before I even get started, let's just write down what the distance formula is. If you recall, the distance formula is nothing more than Pythagoras' theorem. So if I were to write down the Pythagorean theorem, I get that. So the distance formula is the same thing. Distance equals the square root something squared plus something squared. So what are those squared things? Well, this is going to be x sub 2 minus x sub 1, and this will be y sub 2 minus y sub 1. Okay, so let's try to figure out what we know first. Let's list all of our possible line segments. So I have a line segment AB, and let's see, where is that line segment AB? Well, that line segment AB is from that point to that point. And I'm going to put the line right there. Okay, so that's that segment. That's segment AB. And then I have another line segment. I have line segment BC. And BC is right here. This is BC. That's green. And then I have the last line segment, which is AC. Which is that segment right there. So let's write that down, AC. And that one was my purple. Okay. So that means I'm going to have to find the distance of 1, 2, 3 segments. So I have to do the distance formula 3 times. So what do we know about segment AB? Well, we know segment AB starts at the quadrant -4, 7 and ends at B, which is the coordinate 6, 2. Okay, let's just do that much right now. So using the distance formula, I am going to substitute in my points. Before I substitute in my x and my y, I want to make sure I don't get confused. So I'm just going to label this x1, y1, and this one x2, y2. If you do that every time, it will keep your brain from getting confused. So that means that my distance, we're going to call this distance 1. My first distance is, for AB, I'm going to substitute in x sub 2, which is 6, minus x sub 1, which is -4. Ooh, be careful here. Notice how I had to write that. So notice this is x2 minus x1. So this is x2 minus x1. x1 was negative. Notice how I put it in parentheses. Don't forget the square. Plus y sub 2. Well, y sub 2 is 2. Minus y sub 1, which is 7. And that's all squared. Okay, now according to PEMDAS, I have to do what's inside the parentheses first before I can do the exponent. So that means I have the square root. 6 minus 4. Well, this turns into a plus because a negative times a negative is a positive. So that's going to be 6 plus 4, which is 10. I'm going to keep that parentheses there. We'll see why on this side over here. Plus, what's 2 minus 7? Well, that's negative 5. If I don't keep that parentheses there, I'm going to make a mistake right here when I square negative 5. So 10 squared is 100 plus negative 5 squared. Well, that's negative 5 times negative 5, so that gives me a positive 25. So that's going to equal the square root of 125. Now technically we can clean this up because there's a perfect factor that's a perfect square underneath that radical, and we'll learn later that you can't leave that like that. But for right now, what I'm concerned about is that you're learning how to use the distance formula. So we're just going to leave our distance for AB because that was distance 1 is 125. Notice I did not put a line over my AB. So that's that answer. Okay, so let's go back and look at BC. What do we know about BC? Well, BC starts at 6, 2 and goes to 3, negative 2. Okay. Excuse me, because I'm a little lazy, I'm going to use these labels up above here so I don't have to write them again, but I could. So we have to do our distance formula all over again for that one. So let's do that. So this time, instead of writing D sub 1, I'm just going to write BC. Okay, so that's going to be the square root x sub 2. Well, x sub 2 is 3 minus x sub 1. X sub 1 is 6. And that's all squared. Plus y sub 2. Well, y sub 2 is negative 2. Minus y sub 1. Y sub 1 is 2. And that's all squared. So that means that this is, remember PEMDAS, have to do what's in the parentheses first. I'm going to write my answer and leave it in parentheses. 3 minus 6 is negative 3. So I'm going to keep that in parentheses like that. Plus negative 2 and negative 2 is negative 4. Negative 3 squared, well, that's the same as negative 3 times negative 3, which is 9, plus negative 4 squared, well, that's the same as negative 4 times negative 4, which is 16. Well, that's 25. but I know 25, square root of 25 is a perfect square. So BC equals 5. Okay. In fact, because this is getting so long, I'm just going to write the answer over here. So BC was 5. And the length of segment AB was the square root of 125. But I do need to write my answer like this because I'm looking for the distance. Okay, we have one more. AC. AC is right here. So let's look at that. So before we even get started, you can see I'm anxious to write that formula. Let's write our coordinates. Well, C is 3, -2, and A is -4, 7. It really doesn't matter which way I put those. I could have done it the other way around. I could have put point A first and then point C second. Now we're going to look for the distance between A and C. So x sub 2, oops, I think I should label these because those labels are too far away. So this is x sub 1, y sub 1, x sub 2, y sub 2. Okay. So x sub 2 is -4 minus x sub 1 is 3. And that's all squared. Plus y sub 2 is 7 minus y sub 1, which is a -2. Let me get this on the paper so we can see it. And that's all squared. It's really important to make sure you put whatever you're substituting in for your variable in parentheses, especially with those negatives, because otherwise you're apt to make a mistake. So now I have -4 minus 3, which is -7 squared, plus, well, this is 7 minus -2. This is a negative times a negative. That gives me a plus. So 7 plus 2 is 9, and that's all squared. It's -7 squared is -7 times -7, which is 49. 9 squared is 9 times 9, which is 81. Okay, so 49 times 81 is 130. So that's what AC equals. So if I go over here, AC is 130, but I'm going to write it like this. The distance of AB is square root of 25. The distance of BC is equal to 5. And the distance of AC is equal to 130.